Okay, so what we need to remember about today is that the atom contains protons and neutrons in the nucleus, and the electrons are contained in shells outside of the nucleus. Now, in a neutral atom, the number of protons, neutrons, and electrons will be equal. What we also need to remember is that the shells have a capacity. For our purposes, the first shell is 2, the second shell is 8, the third shell is 8, and the last shell that we're going to have to talk about is 2. So you need to remember 2, 8, 8, 2. The next thing that you need to remember is that the outer shell is called the valence shell, and that's the shell that will determine the reactivity of the atom. Okay, so I am going to look at the periodic table to find an atom that I can use as an example. Okay, let's look at the element lithium. Okay, the lithium atom has an atomic number of 3, which means it has 3 protons in its nucleus. And the neutral lithium atom will also have 3 electrons. So if we look at the shell directly adjacent to the nucleus, this shell will have 2 electrons in it. And because lithium has 3 protons in its nucleus, we are going to assume we're talking about the neutral atom, which means we put 2 of those electrons in the first shell because that's all it can handle is 2, and the third electron we're going to put in the next shell. Okay, so the valence shell is this outer shell. And this shell actually determines the reactivity of the atom. If the atom has a valence shell that is not complete or not full, the atom will be more reactive than an atom with a valence shell that is full or close to full. What we talked about today was satisfying that valence shell, making that valence shell full or close to full. And what we need to remember is in the periodic table, as we go from group 1, which is the leftmost, to group 18, the rightmost, the energy to remove an ion or an electron from its valence shell increases. And we call that ionization energy. So these elements in this first group have very low ionization energy, and we proceed to the elements in group 18 with very high ionization energy. Now the ionization energy, remember, is the energy that it takes to lose an electron, to get an electron away from the atom. So these guys actually want to give away their atoms, their electrons, because these atoms have 1 electron in their valence shell, so they're trying to get rid of it. These elements, which are, remember, called the noble gases, these elements are trying to keep their electrons the way they are. Their valence shells are full and they're very, very happy. So as we go from left to right, the ionization energy increases. So the amount of energy required to remove an electron from the valence shell increases. So let's take a look at an example. So we have, let's say, sodium, which has an atomic number of 11. So that means it has 11 protons. And that means if you go to the first shell, you'll have 2 electrons. The second shell will have 8, for a total of 10 so far. But we need 11, so we need 1 more shell, and that's the valence shell, and the valence shell has 1 electron. And so sodium actually wants to give away that electron, and when it gives away that electron, sodium then becomes positively charged because it has 11 protons and only 10 electrons. So if we go back to the periodic table, these elements will all give up an electron to become cations, or positively charged ions. And as you go over here, these elements tend to accept electrons from elements on this end, so they tend to become anions, or negatively charged ions.